Okay, chapter 3, 3.1. We are looking at pairs of lines and angles. In this lesson, for sure 3.1. Should be a lot easier than the last two lessons we went through in chapter 2. So let's get right into it. Number 1, we are going to write the number of points of intersection of each pair of coplanar lines. Okay, so what we're looking for is the number of points of intersection. These two lines are parallel, so how many points of intersection are there? Well, there should be 0, right? That's the definition of parallel lines. They do not intersect. This one looks like they're intersecting right there, so we'll say there's one intersecting line there. And then C says coincident lines. Okay, it looks like there's one line there. But there is, in fact, actually two lines. Okay, I can draw that second line. They're both on the same line. And they're both going on forever and ever. So, how many points of intersection are there? Well, there's one here, 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 and they go on forever. So how many points are there? Well, it's actually going to be an infinite amount. Okay, I'm going to erase this so I can move down on my board. Part 2. What we're doing is looking at this rectangle, this 3D image, and we are going to classify each of the following pairs of lines as parallel, intersecting, coincident, or skew. Okay? Then we're going to justify. We're going to give a reason. So, line AB to start. Line AB. AB is right there, goes on forever and ever. And line BC, you can draw it through there. Okay. Those are intersecting right there, right at point B, right? So we can say those are intersecting lines. And the reason, I'm going to say point B. They intersect at point B. B, it says line AD. AD is right there. And line BC. Okay, those two lines, those are parallel. And the reason for that is those two lines will never intersect. Okay, how do we know that? How do we know that maybe they will in time? It says right here, all angles are right angles. Okay, so those two lines are definitely parallel, they'll never intersect. Reason? Same plane. And will never intersect. Perfect. Okay. Part C says line EI starts at E and goes through I. It's the same direction, right? Lines go on forever and ever in both directions. And line IH, I'll draw the one in blue. Line IH. Okay, it's on the same line. There, two lines on the same line is what we call coincident. And by reason, I'm just going to write same line. Okay? You can write what you need to there. I'm just going to write same line. That's what helps me remember what coincident means. Okay, line BF. Line BF is right there. Okay, and if you were to think this is a 3D image, right? And line EH. So with my drawing, my two blue lines, they look like they're going to intersect. But this is a 3D image. So line BF is behind line EH. So those two lines won't actually intersect. They're not parallel by any means. That doesn't look parallel. And they're not coinciding. So those are what we call skew. So Those are skew lines. So I'm just going to write different plane. And they do not intersect. I'm just going to write different plane. And don't intersect. I'll write it. Helps me remember. Okay. Part E says line EF, which is right here, okay, and line CG, which is right here. Again, those are two lines, not on the same plane. They don't intersect. They're not parallel. They're not coincident. So again, they are skew, and my reason, same reason as the one above. Okay, last one. Last one says AB and GH. Okay, look at this one for a second. Those two lines, from the image shown, doesn't look like they're on the same plane. Okay, but these two lines are parallel. Okay, and the reason for that, stick with me here, is if we were to take this 3D image, this box, when we were to cut this box in half at kind of an angle through AH and through BG. Okay, if we were to cut that plane at an angle with a knife, right, then we'd have this plane in green, right? That is a plane. Okay, it doesn't look like it's there, but it's there. We can create that plane. That's why those lines are parallel. Okay, and I can say they are on the same plane. I'm going to say plane ABG. Oh, that's good in red. Plane ABG. That's what I just created with the green lines there, what I cut in half. Plane ABG, so they're on the same plane, and they don't intersect. Okay? I'm going to move on to the next part. I'm going to erase this. Moving on. This next part, in the figure, two parallel lines are intersected by a third line called a transversal. Understand that word, transversal. So, these two lines in red, I'm going to draw them in red. Oh, smartboard being fun again. Let me erase that. Sorry about that. These two lines in red are parallel lines. This line in green intersects those. That's what's called a transversal. The green line is a transversal. Okay? So, identify all pairs of vertical angles and explain your reasoning. Remember, vertical angles. Vertical angles are across the x. So, in my little figure here, 1 and 3 are vertical angles, 4 and 2 are vertical angles. They're across the x. So let's go to the image that they give us. What are vertical angles? Well, let's start with angle 1. Angle 1, and what's across the x? Angle 3. Okay, those two are vertical angles. How about angle 2? What's a vertical angle with angle 2? Angle 4. Moving over, angle 5, and angle 7, angle 6, and angle 8. Okay, that should be somewhat of a review from chapter 1. So those are my vertical angles. Explain your reasoning. I'm just going to say across the x. Okay, because that's what helps me remember. Explain your reasoning. So why do you remember vertical angles? B says identify all the linear pairs of angles. Remember, linear pairs are two angles that make up a line. Right? So on the same line, they make up 180 degrees, and they're two angles. So let's start with angle 1. And what makes a line with angle 1? Well, angle 2 does. Right? Angle 1 and angle 2. Those are on that transversal line. They make up 180 degrees. Okay? There's another one with angle 1. It's angle 1 and angle 4. Okay, those are on one parallel line. They make up that line. There's another one with angle 2. Angle 2 and angle 3. And those are linear pair. There's another one with angle 3 and angle 4. Those are a linear pair. So there's 4 all right here. There's 4 of them. There's 4 more to go, right? So we have this group of 4 over here, right? So let's start with angle 5. Angle 5 and angle 6 are definitely a linear pair. Angle 5 and angle 8 are definitely a linear pair. Angle 6, oh, not 8, 6, angle 6. Angle 6 and angle 7. And then angle 7 and angle 8. Those are all my linear pairs. I'll let you explain the reasoning why it's a linear pair. They are two pairs of lines that make up one line, or a line, and they make up 180 degrees. Looking down here, what does it mean when two lines are parallel, intersecting, coincident, or skewed? Parallel. They don't intersect. On the same plane, sorry, don't intersect on the same plane. Okay. I'm going to scroll down to see if we're not supposed to do these definitions down here. We have parallel lines and skew. We don't have intersecting or coincident. Intersecting, I would hope we all know what intersecting lines are, right? Intersecting, we have a line and we have another line and they intersect. Right there, where the two lines cross. Coincident, coincident, I'll write in red here, are two lines on the same line. Okay, so if I have my line here, and my other line in green on that same line. Okay, those are coincident lines. There's two lines on the same line. Okay, and I will define skew a little bit lower. I'll let you do number 5. Work on number 5. You can pause the video and come back. Here I'm going to define these. So parallel lines. Actually, I'm going to stop the video. This will be part 1. Part 2 will be soon to come.